So yeah, a compound inequality is an inequality formed by joining two inequalities with the word and or the word or the word or. So when you graph a compound inequality that has an and statement, it is the what we call the intersection. Make this a little easier to read here. The intersection of the two graphs of the inequalities. So that's kind of what I was showing you up on the board, is you look for where the two arrows are overlapping, and that'll be the solution set for the compound inequality. The graph shows the numbers that are solutions of both inequalities. So it's got to satisfy both pieces in order to be a solution to the overall set. So I don't know why this printed kind of funky like this, but basically, like if you had x is greater than or equal to 2, you have 0, 2, closed dot going to the right, x is less than 5, try to squeeze this on here, 0, 5, that'd be an open circle going to the left. If I said x is in between 2 and 5, including 2 but not 5, or I state it something like this, x is greater than or equal to 2 and x is less than 5, you'd have a closed circle on 2 and an open circle on 5, like this. Okay. The graph of a compound inequality with or is what we call the union of the graphs that are inequalities. So you're joining two sort of distinct sets. Instead of finding like what's true for both of them simultaneously, you just need to find what's true for both of them individually and just kind of group them all together. So that's what I mean by union. The graph shows numbers that are solutions of either inequality. Right? So it doesn't need to solve, an x value doesn't need to satisfy both, it just needs to satisfy one of them, just one or the other. If I have y is less than or equal to negative 2, I'm going to look like that. Y is greater than 1. I don't know why I put that there. Look like this. And then again, I'm not sure why this printed like this. And it looks kind of funky. But basically, between negative 2 and 1, you'd have nothing. You'd actually have arrows going in this direction. So part of what we're going to do is interpret these phrases and write them as compound inequalities. We're also going to graph them, and then we'll get into how to solve them. And that's going to pretty much be the overall idea for today. So let's look at a couple of these examples. It says a number u is less than 7 and greater than 3. So this is going to be an and inequality where we're satisfying u is less than 7 and greater than 3. So what I would do is sort of write them both separately, and then with these and inequalities you can make it a little nicer like we did up on the board, make it look a little cleaner. You can't really do that with the ors because they're not overlapping, but let's see how we would write this. So first I would say, okay, well u is less than 7 and u is greater than 3. So if you leave it like that, that's okay. But typically the way I'm going to write it when u is sort of in between two different numbers is to write it like this. So u is greater than 3 and less than 7. So your and inequalities will normally look like this. They're in between two numbers. When you go to graph them, you'll just, let's see. Am I going to be able to count this out? 1, 2, 3, 4, 5, 6. Oh, look at that. So 1, 2, 3, 4, 5, 6, 7. When you're trying to decide on the open circle versus the closed circle, you make the decision in the same way. Just be careful. Like in this case, it's not really going to make a big difference because they're both the same. But you want to be looking at the symbol that's sort of attached to that number. So at 3, I would have an open circle. And at 7, I would too. But it is possible to have like one or the other, like one open, one closed. We'll see a few of those. And then connect the dots. So In an and inequality, your graph is going to look like this, just like we did up on the board. An or will look like something like that over on the right-hand side. A number S is no less than negative 2.4 and fewer than 4.2. So on an and inequality, you're really looking for, like, what are the two numbers? What's the lower limit and what's the upper limit? So what is the lower limit? Like, what's the least it could be? Negative 2.4. And it says no less than that. So one other thing you have to think about is, like, well, could it actually be negative 2.4? If it's no less than that, then yeah, negative 2.4 is not less than itself. So that should work. So we'll have less than or equal to our number S and fewer than 4.2, so less than 4.2. Now, because of the way this printed, I'm just going to make my own number line here, so I don't have to, like, squeeze it in underneath here. So here's my number line. I've got 0, negative 2.4 over to the left, 4.2 over to the right. And in this example, I do have one closed, one open. That's okay. You know, don't let that happens. Okay, so that's what your and inequalities will look like. We don't really have a fancy way of writing the or inequalities. You just literally write the word or in between the two inequalities. So let's do a couple of or problems. All right, so a number D is less than negative 2 or greater than or equal to 2. So when you have an or inequality, you have to set them up sort of separately, okay? D is less than negative 2 or D is greater than or equal to 2. Sometimes the or ones are easier because you're just literally just graphing two inequalities on the same number line. You don't have to think about, how do I connect it or any of that. You just write them out exactly how it says, and you should be good to go. So got 0, negative 2, 2. On negative 2, I should have an open circle because it can't be equal to, and the arrow should go to the left. And if it's greater than or equal to, I'm going to have a closed circle pointing to the right. And that's that. Yeah. So you'll have these two sort of disconnected arrows for the or inequalities. All right, number 4. A number C is more than negative 4 or at most negative 6.5. I don't really like that mixed number, so let's convert it to a decimal. It's negative 6.5. So C is more than negative 4 or C is at most negative 6.5. So at most, what symbol should we use for that?
Less than or equal to?
Yeah, less than or equal to. Okay, so I've got 0, negative 4 is somewhere over here, negative 6.5 is somewhere to the left of that. I guess I could actually put this the way it's supposed to be. I've got enough room here. So let's see, 0, 1, 2, 3, 4. And 6.5 would be like right about here. Closed circle going to the left on negative 6.5, open circle going to the right at negative 4. And so any value that sort of falls underneath these arrows will be a solution to the compound inequality. So like 0 is a solution. Negative 10 is a solution. Just not what's in between. Any questions so far? Okay, so the solving part of it, I think that's where it gets a little trickier. It's not crazy difficult, but you're sort of solving two things at the same time, especially with the and inequalities. That's where they get the most, I don't know, difficult, I guess. So you can solve a compound inequality by solving two inequalities at the same time, or simultaneously. So you can solve them at the same time. When a compound inequality with and written as a single inequality, you can solve the inequality by performing the steps on each expression. Okay, so what does that mean? So like on number 5, if this just looked like, let's cover up the 4 less than for a minute. If this was your inequality, what would you do to solve for x? Add 3 to both sides, right? When you have a compound inequality, particularly an and inequality, you want to do that exact same thing, but since there's not just 2 sides to this inequality, you have to do it to all 3 sides at the same time. So I do want to add 3, but I want to add 3 here, here, and here. So this is sort of a pretty big shift from what we've done before. So you add 3 to each of the 3 parts. And so what you get is 7 is less than x is less than or equal to 10. It's not that bad. You just have to know what to do. Is this going to fit 1, 2? Oh, this is going to work out great. So 0, 1, 2, 3, 4, 5, 6, 7. And you don't have to space it out perfectly like this. I'm just doing it because we have the space. So it goes from 0 to 10. Okay, wait a minute. Which way are the arrows going to go? Are they going to like connect, or are they going to go opposite of each other? Are they going to go to the left or the right, or are these two going to be connected? Yeah, connected, because the solutions are in between 7 and 10. For number 6, what do we need to do? Yeah, you can go ahead and say it. Yeah, well, what do we need to do here? Divide by what? -5. When we're dealing with inequalities, though, don't forget about what happens when you divide by a negative. What do we have to do? Yeah, we've got to flip the sign. So we have 2 signs here, so make sure you flip both of them. So we get -3 is less than or equal to g is less than or equal to 2. Now you should see that like these numbers should be in order. So if they're not, that would be like in other words, if I forgot to do that, it should throw up a red flag that I have a statement saying that 2 is, you know, smaller than -3, which it's not. Now the order is correct. So you can look at the order of these numbers and make sure that they're good. Okay, so that's my solution set. G is any value between -3 and 2, including -3 and 2. So here's 0, -3, 2. It looks like both of these are going to be closed circles. And the solution set will be all the values in between and including those endpoints. Okay, well, those are 2 problems where we're solving an and inequality. So let's look at what happens when you're solving an or compound inequality. These are actually, I think, a little bit easier, even though they're a little bit more work. Sort of weird to think about, but the reason I say that is because you essentially just solve these 2 inequalities separately. It's not like you're solving 2 problems in one. Okay, you don't have to worry about doing the same thing to every single side when you're dealing with an or inequality. You solve them independently. So like for number 7, I'm going to subtract 4 on either side here to get z is less than -2, or, and here I divide by -3. So I just solve them both independently. Divide by -3, divide by -3, gives me z is greater, less, what are you guys thinking? Greater than or less than? Yeah, why is it greater than? Yeah, we divided by a negative, right? So don't forget about that. That dividing by a negative is just going to keep coming up. So that's my solution set, and that's just how you write it. They're just two separate statements. Okay, I'll rewrite or just to help break it up a little bit. Yes, there you go. Get two different colors in there. And then when you go to graph it, you just graph them independently. So z is less than -2. I don't think I'm going to be able to fit all this in here, so I'm just going to kind of make up this scale here. So less than -2, or z is greater than, I'm just going to stick 9 somewhere out here. 9. And it's okay if it's not perfectly to scale. That's fine. Number 8, we've got 2t plus 6 less than 10, or -t plus 7 is less than or equal to 2. So just like the last one, we're going to solve them independently. Here I'll subtract 6 from both sides to get 2t is less than 4. Then divide both sides by 2 to get t is less than 2. So that's half of it. All right, then we have this or. Subtract 7 from either side to get -t is less than or equal to -5. Divide by -1 on both sides. And we get t is, after we flip the sign, greater than or equal to 5. So I go to graph this, I get 0, 1, 2, 3, 4, 5. Open circle on 2 pointing to the left. Closed circle on 5 pointing to the right. And that's it.